Right, so hopefully everybody did a good job with 11.2. So now we want to move on to a kind of a two variable chi-squared test. So for the one variable was a goodness of fit. So in this case, what we're going to do is be testing the independence of two different variables. So before we get started, we need to see how the data is going to be given to us. So in this case, we're going to be using what's called a contingency table, or you can think of it as a matrix. So if you've done matrices before, we're going to use this as a matrix in this case. And so what we're going to get is we're going to get a row variable and a column variable. So like in this case, our column variable is going to be our major, and our row variable is going to be the hours studying per week in this case. And so what you'll end up doing is you'll need totals for all of these, but you'll see like what we need to for the calculator is just going to be this part of it. So we won't use the totals, but we will need the totals of all these to help with calculations and stuff like that. So, all right. So how to find the expected value. So technically it's exactly the same way, the expected value is a little bit, to find the expected value matrix in this case. So what you're going to do is take the row total. So like in this case above, so I think I did one here. Which one did I calculate? Yeah, so in this case, the row total for humanities I added up was 345. And the column total for hours studying per week 0 to 10. And then humanities was 257. And then the total, I think, was what, 1,000? Yeah. So like if you add up this and this will be 1,000. So to figure out the expected value for this one position, you take the row total and the column total where they intersect, multiply them together. So that's where we get the 345 times the 257. And then divide that by the grand total, which in this case was 1,000. So in this case, we see that, what do we get? 88.665. So the very first position of our expected value matrix would be 88.65. So notice there's 12 positions total, so we'd have to do this 11 more times to figure out the calculation. So that is one of the tricky things about this section. So because there's a lot of work that kind of goes into it. It's just, busy work. It's not terribly hard, but you do have to you have to fill out the expected value matrix before you can pretty much do anything else. All right. So in this case, so the chi-squared test statistic. So again, this is just like the same formula as we saw before, but hopefully you notice that I've got like an I and a J down at the bottom. So, because the problem is what we have to do is actually go through and calculate the differences in each of the different positions. So in this case, like what I showed above, so the original matrix above was a 68, and then we calculated the expected value to be 88.665. So then what you'd do is you'd go through and do 68 minus 88.665 all over 88.65. Oops, some typo there. And then divide them out. And so this would give you that first position. And then you'd sum all those guys together. So this is a lot of work goes into trying to do these by hand for certain. But just to give you an idea of like how much work goes into these, a little trickier. So p-value is exactly the same, so there's nothing different about the p-value. So now the way we're going to find the p-value is a little bit different. So in this case, what we have to do is actually enter all these things into a matrix. And so if you notice, I've highlighted second matrix, which is the X inverse button on the calculator. Go to edit, enter the size of the matrix, so it's always going to be the rows times the columns. And always make sure the A matrix is the observed and the B matrix is going to be the expected value matrix. And once you type those in, then you'll go to the stat button, and then we'll have a chi-squared test that we actually use from the test menu. And so this will tell us exactly what the p-value is so we can know whether to reject or fail to reject and stuff like that. So, all right. So that's kind of the background information on what we need to know. So now our testing for independence. So again, this is the same four-step process that we've had before. Now in this case, since it's a two variable, our degrees of freedom are based on the rows and the columns. So just take the row minus 1 times the column minus 1 to get our degree of freedom so we can figure out what our alpha level is on the that table. So we're still going to use the same table to find our alpha. So in this case, there's no less than, equals, none of that stuff. So we're basically saying that the two variables are independent is the null hypothesis. The two variables are dependent is the alternate hypothesis. So again, there's our test statistic, just like I showed you a little sample of above. You know, our calculator p-value, we're using our chi-squared test. So we can also, once we find our test statistic, we can do the whole, so chi-squared CDF, our test statistic, whatever it was, 100,000, and then our degrees of freedom. So we can use that too, so that way we don't even have to use the chi-squared test, like we wouldn't even have to put the matrix in there if we can figure out an easy way to calculate the test statistic. And then draw a conclusion, so again, same exact stuff. All right, so let's look at an example here and see if we can figure out what's going on. So in this case, our example, Titanic survival rates. So the table below describes the fate of the passengers and crew aboard the Titanic, which sunk on Monday, April 15th, 1912. The two variables for this problem are the row variable, which indicates the type of people, or whether they survived or not. So survived, so there's the top total is the number of people that survived. The bottom are the number of people that died. And then the column variable is the types of people, so men, women, boys, girls. And using a 0.05 significance level, test the claim that when the Titanic sank, whether someone survived or died is independent of whether the person is a man, woman, boy, or girl in this case. All right. So our H naught is that just like we have up here, so the two variables are independent. So in this case, whether you survived or died is independent of whether you're a boy, girl, man, woman. So I don't know how to word this, like demographic. We'll do that. So I don't have to write the whole thing out. So H1 is dependent of demographic. All right. So calculate the test statistic. So before you can do anything with the test statistic, we have to come up with the expected matrix. And so in this case, you can see, so again, when you're looking at your matrix, again, don't count the totals in here. So we're just looking at those. So this is 2 rows by 4 column matrix. And so let's come up with kind of our expected value matrix first here. Again, so this will be men, women, boys, girls, survived, died. So again, to figure out what goes in that first position, we're going to do 706 times 1692 all divided by 2223. Oh, let's see. I forget what I wrote in there. So 537.36. So basically what we're doing with the expected value matrix is trying to come up with sort of an average of what should have occurred. So in reality, if it was kind of evenly distributed, what would we have actually gotten in that case? So then for the women position, we're going to do, oops. So we want to take this, oh, don't erase. So we're going to take the 422 times the 706 all divided by the 2223. So 422 times 706 all divided by 2223. All right, so in this case, now that I've got this first one in there, I can cheat a little bit. Oh, whoops, hold on, I messed that first number up. So let me go back. You need to put parentheses around the top. Oh, it's the same. Okay, don't worry. All right, so now, in this case, I'm replacing the 1692 by 422. So 134.02. And then boys, we're going to get, oops, the 706 again, times 64, all divided by 2223. So again, if I go back, I can just replace that one number. Whoops. So 20, just 20 pretty much even. Oh, except I use 63 instead of 64. You do want to use the right values, otherwise you'll, so 20.3233. And then finally the girls, so we're going to do 706 times 45, all divided by 2223. So 14.29. And now we want to do the exact same thing for the dyed ones. So in this case, we're going to use the 1517 as the top number times the 1692 first, all divided by 2223. So 1154.64. And then in the next position, we're going to use the same 1517, but now 422 all over 2223. So 287.98. And then for B, let's see, so we've got 1517 times 64 all over 2223. So 43.67. And then finally 45 times 1517 all over 2223. So 30.71. All right, so at this point, we actually haven't done any work at all. All we've done is actually gotten the expected value matrice. So we still have to actually calculate the observed value and all that stuff. So I'm going to stop it here for a second just to make sure you've got that part down, and then we'll come back later and finish up how to do the find the actual chi-squared statistic.